All right, lesson 4.7 is called transforming formulas. But first, I want to go over another method of multiplying a binomial by a binomial. And this is really not very different from what we did in the last lesson, but I refer to this a lot. This is how I learned, and we use this method called FOIL. And FOIL just stands for first, outside, inside, and last. And when you look at how we do this, the first number in each parentheses would be the 2x times the x. So we do 2x times x. Now that looks just like how we distribute, which is true. This is really not any different from distributing. Then we would do the 2x times the -3. Those are both the outside ones. So 2x is on the far left and -3 is on the far right. So 2x times -3. And then we do the inside. So 6 times x. And then we do the last ones in each parentheses, the 6 times the -3. So I just use this to refer to because it helps me to draw my rainbows correctly, to make sure that I've distributed everything, but really it's just a distributive method. When we have two binomials, most of the time we have an x in the first term and a constant in the second term, an x in the first term and a constant in the second term. If that is the case, then you will find that the outside and the inside, or what I like to call the OI terms, will be added together. They will both have an x without an x squared. So here we had 2x squared, -6x, a +6x, and a -18. When we add all of these together, the -6x and the +6x will cancel and be 0. And so we will get 2x squared minus 18 for the answer to this problem. So let's practice one more time. Here, our first ones is going to be 4x times 2x, which will be 8x squared. We'll then have the outside terms, 4x times a -1. The inside, -2 times a 2x, so that's going to be a -4x. And then the last one's -2 times -1, which will be a +2. We add these together and we're going to get a -8x and then a +2. So final answer right here, I didn't have to write the plus, but I did. That's okay. So final answer to multiplying this one. And so I just think that FOIL is easier to help you keep up with how you would distribute. So feel free to use that in any time when you're multiplying binomials. The FOIL acronym only works for a 2 by 2, so a binomial times a binomial. If you get a trinomial in there, then you'll just have to draw your rainbows and make sure that you distribute everything correctly. But you'll see in the coming chapters that we are often multiplying binomials by binomials. All right, so transforming a formula is a way of solving a formula for a certain variable. It's the same as solving for one variable, only we're going to have only letters to work with instead of numbers that we're actually going to do computations with. So remember that when we are solving an equation or undoing an equation, we're going to work PEMDAS in reverse order. So here in this one, area is side squared plus 2RS. At least I think this was, I don't know what this is. Anyway, it's a formula for something. If we want to try to solve for the R, then how do we get the R by itself? Well, reverse order, we're going to work with addition and subtraction. So what is added to what's in the R term? Well, the S squared. So first we're going to subtract the S squared. So we do that on both sides. And over here, that becomes 0. So now there's nothing left that's added or subtracted to the side with the R. So we're going to look at the next things, which would be multiplication and division. So the 2 and the S are both multiplied to the R. We can divide them at the same time. So here, if we divide by 2 and S, that will cancel the 2 and the S on this side. If we divide by 2 and S, we just have this really ugly fraction, but we're going to leave it that way. And we have solved for R, and that's it. So it doesn't solve pretty and give you a nice, pretty answer, But now if we're doing a calculation in science where we have many inputs, like we've done an experiment and we have to calculate 5 times, because we did the experiment 5 times, we had a little different number each. It is going to be easier to plug it into something where you plug in all the variables and you come out with the answer, rather than plugging it all in to start with and having to solve for the R every time. So sometimes it is easier to transform the formula, especially if you're going to use it over and over again. So here we have F equals ma, which is force is mass times acceleration. So that's a physics equation. We want to solve for the A. So we want the A by itself. Well, you can see here, all we have with it is multiplied by the m. So we're going to divide both sides by m, and that will leave us A by itself, and the other side is F over m. So that one's pretty simple. Sometimes they get complicated and ugly, but just remember to keep it all together and don't worry that it's ugly in the end. Solve A equals P plus PRT for T. So we're going to solve for this one right here. So again, now that I'm looking at this whole side where T is, I see that I have something added to it. So reverse PEMDAS order, I want to start with addition subtraction. So I'm going to subtract the P from both sides. I will have A minus P equals PRT. And now I have nothing added to that side with the T, but I do have things that I'm multiplying. So I'm going to divide the other things that are multiplied to T. And that cancels them. So now T's by itself, which is what I wanted. And what does this side look like? A minus P on top and P and R on the bottom. So again, a little bit ugly, but that's how we're going to leave it. Solving L equals A plus n minus 1 times D for this n. So right now, the n minus 1 is in parentheses. That's going to be at the end of our PEMDAS when we're working in reverse order. So the first thing we want to do is the addition subtraction. We're going to subtract the A from both sides. And we'll have L minus A equals n minus 1 times D. Now again, the n minus 1 is in parentheses, so I'm going to want to divide that D first. Now the n minus 1 can come out of parentheses because that's the only thing on that side of the equation. And then I'm going to have to move that 1 over, and I'm just going to add it just way in front of everything. And so my final answer is n equals 1 plus L minus A over D. So again, this procedure is very helpful in your science classes. You might be given a formula, need to solve for a variable in the middle, and it can be helpful to transform that formula so you can just plug in numbers and solve for your variable more easily. Again, most of the time, that's going to be when you have to use it over and over again for different numbers. So the last thing I want to talk about is problems without solutions. So that would be something like you're given a word problem and you do all the math correctly. Maybe you're trying to find the area of a rectangle because it's the area of a garden and you're giving it to relation to another one. You solve it all correctly. Your formulas are correct, your math, your computation, but you get that the garden should be -5 feet by 20 feet. In that case, that's not possible. That problem can't have a solution with a negative number. So you would say no solution. Now, again, make sure that your math is correct and that you put in your equation correctly. But if you did all that and you still got that it should be -5 feet, we know that we can't have a length that's a negative number. So that would be a no solution problem, that somehow when they designed that problem, it just didn't work out. You just can't have that. Another thing that might come up is maybe they're trying to figure out how many cases of water you sold to a customer, and you do all your calculations, and in the end, it's 14.25 cases. I don't think that most stores break up a big box or a case when they're selling it. So you can't sell 0.9 pencils. So If you come up with a decimal or a fraction on something that should be a whole part, then you would know that that's another problem without a solution. Sometimes you're going to read the problem and just not have enough information. That problem, when you read it, they give you all these things, but when you look at it, there's no actual way to solve that. So you might just write that the problem doesn't have enough information to solve. So we have a whole lesson on problems without solutions. And when I assign the homework, what I really want is just for you to look at that problem and say, if I solved it, what numbers would be unreasonable? So lengths or areas that are negative numbers, something that should be a whole number comes out as a fraction or a decimal, or a negative number. You can't sell -3 pencils. So those are the types of things that you're looking for on those word problems. You're not asked to solve them. Just give me some ways that you would get a solution that you would say, oh, wait, that can't happen.